In part 2 of this lesson, we're going to explore how factoring relates to graphing. So we've spent some time in this unit already graphing quadratic functions, but we've been graphing them from a standpoint of using the vertex to start the graph. So we've explored vertex form and we know how to make our graph shift left and right and up and down. What we're going to talk about in this lesson is how to use the roots or zeros of a quadratic function. So the vertex, you know, is either that lowest point or the highest point if the parabola was pointing upside down. But what we are going to talk about are the places where it crosses the x-axis. Now, most parabolas, you're going to see it cross the x-axis twice. Some of them may only touch the x-axis once. Some of them may not touch the x-axis at all. But these points where it does cross the x-axis are very important to us. There's a couple of vocabulary words that you could use that are associated with those 2 points. You could hear these points called x-intercepts, which makes sense because it's where it's touching the x-axis. Another word that you could use for those points would be the roots of the function. And yet another word that I'm going to emphasize here, these points are also called the zeros of the function. And that's going to be really important to us because if I ever ask you to find the x-intercept or if I ever ask you to find the roots of a quadratic function, all you do is set the equation equal to 0. So if you remember that those 3 words are connected, x-intercepts are the same things as the roots, are the same things as the zeros of a function, then you'll remember to set the equation equal to 0. All right. For this section, we're going to write a quadratic equation in factored form and then find the zeros. So looking at number 7, we have y equals x squared minus 6x minus 16. Now the equation right now is written in standard form. And tell us that we want to write the equation in factored form. Well, that's easy. All you need to do is factor it. So we will start off with x times x to get that x squared. And here we need 2 numbers that multiply to negative 16 and add up to negative 6. So 2 numbers that multiply to negative 16 and add up to negative 6. That would be negative 8 and positive 2. Negative 8 times 2 is negative 16, and negative 8 plus 2 is negative 6. So factored form, we would have x minus 8 times x plus 2. This is factored form. Now we also want to find the zeros. All we're going to do is set those equal to 0. So either x minus 8 is equal to 0 or x plus 2 is equal to 0. And if we solve for x, on the left-hand equation, I would add 8 to both sides. You get x equals positive 8. And on the right-hand side, if you subtract 2 on both sides, you end up with x equals negative 2. So basically, if you were to graph this thing, it would cross the x-axis at negative 2, and it would cross the x-axis at positive 8. And that's what your parabola would look like. Now, for the sake of time, number 8 is a lot like number 7, so we're going to skip this and move on to number 9. So number 9, the equation right now is written in standard form. We want to change it to factored form. This one takes a little more effort because what we have in front of x squared is a 3, so we're going to have to send that to the back. So we're going to be working with x squared plus 4x minus 12. So in order to factor this, we've got x and x. We need 2 numbers that multiply to negative 12. And the same 2 numbers need to add up to positive 4. So what 2 numbers multiply to negative 12 and add up to positive 4? That'd be negative 2 and positive 6. Negative 2 times 6 is negative 12, and negative 2 plus 6 is positive 4. So here I would have x minus 2 and x plus 6. But remember, if you multiply by 3 in that first step, you're going to come down here and divide by 3 in order to get your factors. So on this side, 6 divided by 3 is 2, so this side is going to be x plus 2. On the first one, though, 2 divided by 3 is a decimal. You can't have decimals, so you're going to move that denominator up front. That'll be 3x minus 2. Okay, now that is factored form. We also want to go back and find the zeros, so all we do is set those factors equal to 0. So to solve for x, I would add 2. That gives me 3x equals 2, and then divide by 3. So one of my zeros is at 2/3. So I know that this parabola would cross the x-axis at 2/3. The other zero, if I solve for x, I would subtract 2 on both sides, is negative 2. So that tells me I would cross the x-axis at negative 2. So if you picture your parabola, it would cross the x-axis twice, once at negative 2 and once at positive 2/3. All right, moving right along. Example number 10. We're going to write an equation in standard form for each parabola using its roots. Okay. So using the roots, we're going to look at where it crosses the x-axis and put together an equation for this. So it looks like this one crosses the x-axis at negative 4. So I've got x equals negative 4. And it crosses again over here at positive 2. So x equals positive 2. Now, those are the zeros. What you want to do is write your equation in factored form. So if it crosses at negative 4, what factor did that come from? X plus 4. Because if you set x plus 4 equal to 0, you would get a 0 at negative 4. All right, so same thing, let's do the x equals 2. So for this other root, x equals 2, what factor did it come from? If it crosses at positive 2, that means the factor must have been x minus 2. Because again, if you set x minus 2 equal to 0, you would end up with 2 for your answer. Now, if that's kind of confusing for you, remember the rule that we've said every single time we've used parentheses this year? Insiders lie. If it crosses at negative 4, your factor is going to be x plus 4. And if it crosses at positive 2, your factor is going to be x minus 2. Now, the directions did say to write the equation in standard form. This is not standard form, it's factored. To get it to standard form, you just have to multiply these things back together. So x times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 would be negative 8. So my final answer, I would have y equals x squared. And if we combine like terms here, that would be plus 2x minus 8. Again, for the sake of time, we're going to skip example number 11 for now. Right, number 12, this one's very similar to what we just did with the graph. So instead of having a graph to look at, it's just telling you where the roots are, and you're going to set up the equation from there. So here it tells me that I have a point at negative 5, 0. That's on the x-axis at negative 5, so I'm going to write that as x equals 5. Now, if x equals negative 5, the factor would be x plus 5. And then the other root is at 1, 0. That's crossing the x-axis at 1, so we can think of it as x equals 1. And you want to know what factor that came from. It would be x minus 1. And again, if you don't see that naturally from what we did in the first section, you can remember what we talked about all year long. Insider's lie. If it has a root at -5, then your factor is going to be x plus 5. And if it has a root, it is going to be x minus 1. Now again, this is not standard form. If you want to get your equation in standard form, you're just going to multiply this back together. So we can FOIL x times x is x squared. X times -1 is -1x. 5 times x is 5x. And 5 times -1 is -5. So our final answer here is x squared plus 4x minus 5. I'm going to skip example number 13 for now and move on. I'm actually going to skip example 14 also. We're just going to hit number 15, the last one. So this is just like the previous one we did, except it involves some fractions. It honestly doesn't make the problem that much different from what we already did. We have the roots. We see here that it crosses the x-axis at 1/2, so that's x equals 1/2. And we see with the second coordinate point that it crosses the x-axis at -2/5. So we're going to put this together into our equation. Remember insider's lie, so if it crosses at +1/2, then my factor would be x minus 1/2. And over here, if it crosses the x-axis at -2/5, then I'm going to write x plus 2/5. Now remember when we were factoring, you can't have fractions or decimals inside your factor. So what you do is move that denominator to the front. So for the first factor here, 1/2, we can't leave that as a fraction. You're going to move the 2 to the front. So this would be 2x minus 1. Same thing with the second factor. You can't leave 2/5 as a fraction. You'll have to move the 5 to the front. So that would be 5x plus 2. Now this right here is factored form. If you want it in standard form, you're just going to have to multiply that back together. So go through the whole FOIL process, multiply the first two together. 2x times 5x would be 10x squared. Multiply the outside 2 together. 2x times 2 is 4x. Multiply the inside terms together. -1 times 5x is -5x. And multiply the last two terms together. -1 times 2 is -2. So our final answer, if we combine our like terms in the middle, we have 10x squared minus 1x in the middle minus 2.